Hi, welcome everybody, and thank you so much for joining Ask Why, where we dig into technology that shapes tomorrow and break it down in simple ways. Today, we're actually going to break out of the cylinder, literally. We're going to talk about rectangular aluminum electrolytic capacitors. And here with me today, I got Laura, who's the product manager for aluminum electrolytics. And we're just really going to dive into what that shift is towards the rectangular capacitors. So when I think of the aluminum electrolytic, typically I think of a cylindrical can, but today the rectangulars are actually being designed in and showing up more and more in all kinds of applications like onboard chargers. We do see them in more compact modules. So Laura, what is driving that shift?
Okay, so while the rectangular capacitors are volumetrically efficient, so depending on how they're mounted on the PCB board, you can have a footprint savings, or you can even have a lower profile. So if there's, a height constraint, the cover is really close to the board, you're able to take advantage of the low profile of the rectangulars and have a compact solution to fit there in that space.
So for those of you guys that are watching us on YouTube, you can actually see a round aluminum electrolytic capacitor here compared to the rectangular capacitor, so you can get an idea of what that change will actually look like. So let's make this practical. If I'm an EV designer and I'm designing an onboard charger, a DC to DC converter, or anything that really has a high ripple system, where do these electrolytics, the rectangular ones, actually fit in?
Okay, so automotive, particularly onboard chargers and DC to DC converters, they're looking for, in modern designs, high ripple current capability, higher temperature, higher voltages, and even very high vibration resistance. And in our rectangular portfolio, we have the conventional wet lytic and also the solid polymer, and we have a wide voltage range up to 500 volts, so that's meeting that need. Also high temperature up to 125 C, high vibration capability up to 40 G, and then again, the advantage of having that low profile. It works well with these modern automotive and industrial designs that we're seeing currently.
So now one big claim that these rectangular ones have is ripple current. So what exactly is putting that advantage on that rectangular shape?
Okay, so, well, they do have the wide flat surface, and that allows for heat to better dissipate from the capacitor when compared to a cylindrical shaped capacitor. And they work very well with the heat sink, having that flat surface area as well.
So when we talk about a heat sink, it's really hard to visualize putting a heat sink on an aluminum electrolytic capacitor. But if you can look here on the screen, we give you a little bit of an example of what that looks like placing a heat sink on an aluminum electrolytic as a rectangular shaped capacitor. So now when we talk about aluminum electrolytics, I know a cylindrical shape and vibration, they don't typically mix well. But you mentioned that these capacitors have 40 G of vibration. So what is the difference on the rectangular to the round shape that makes them able to handle these high vibrations?
So you're right, we do have families rated at 20 G and 40 G vibration capability, but the key point is that these capacitors must be clamped by the body. And this is true for capacitors that are not surface mount components. And as you can see, these are radials. So that's the key to being able to achieve the max vibration capability. And clamping can be something that it's not like a little bracket apparatus or something like that, but oftentimes we see glue being used or RTV to help secure the capacitors to the board to allow them to achieve that maximum vibration capability that they have.
All right, so do engineers only have a fixed set of rectangular sizes, or can they be customized? Or can they have multiple options available on those rectangular capacitors?
So we do have catalogs, data sheets. So for our conventional wet families and also for our solid polymers, we have various temperature ratings, 85, 105, and 125 C. Voltage range from 63 up to 500 volts. But if a customer goes in and they do not see a capacitor within the datasheet that meets their specifications, we can oftentimes do optimized designs. And it's no additional charge to do that, even if they have a specific dimension that they need. And we offer straight leads on all of our products currently available. We have surface mount available on the wide side right now in production. And then on the roadmap is to surface mount on the narrow side and even use the press fit termination on a rectangular shaped capacitor. And with a press fit, they don't require solder.
So I saw you brought in a little board here. So what can you actually see on that board?
So this is showing banks of rectangular capacitors and showing you the advantages you can have depending on how they're mounted. So if they're mounted on the narrow side, we're taking advantage of freeing up the footprint space. And if they're mounted on the wider side, we're taking advantage of that lower profile that they can have.
And then they're stuck together with an adhesive, and the heat transfer from cap to cap is actually very well? Or
Yes, so when you're having this additional thermal paste in here, a thermal pad, that's also helping distribute the temperature across the capacitors, and it even helps a little bit with vibration capability, kind of helping with the stability of the caps. And it helps to have, because you would think that the capacitor in the middle is getting a lot hotter than the ones on the outside, but that's not the
that was
case
going to be my next question.
with the rectangulars. Yeah.
So, and
I
then
read
of
your
course,
mind.
that makes it easy for us also to place a heatsink in addition to that, right? So even though I have this shape, I can still place a heatsink on top of that.
Yeah, and heat sinks. So heat sinks can be active or passive. A passive heat sink works best with the flat side of the rectangular capacitor. So basically, a passive heat sink is a piece. It's a metal plate. It could be aluminum, and it's making direct contact with the capacitor and something else within the application that can absorb the heat and pull it out. And the benefit of doing that by pulling the heat away from the capacitor is you're increasing the ripple current capability or extending the life of the capacitor and having the same ripple current. And that the heat sink works much better with a flat surface than with a cylindrical shape. It can pull out more heat.
That's really good. But another thing I noticed just looking at the board, there's really no wasted space in between each capacitor. So compared to aluminum electrolytics, do you have a big board space savings in those types of capacitors?
Yes,
or?
we do. So for example, if you're comparing a bank of rectangulars mounted on the narrow side to a similar bank of cylindrical capacitors, you are obviously saving a lot on the footprint because there is a required clearance around a snapping capacitor that must be taken into consideration. And obviously the round shape, there is a lot of void left on the board. The rectangulars could be stacked right up against each other, so you don't have that wasted space. So when this is compared to a bank of similar cylindrical snapping capacitors, the saving could be a total of 35% savings on the footprint.
Wow, I mean, that's a huge improvement.
Yes.
Now, when I see a module like this, you said custom products, could I actually buy a module already designed
Yes.
like that?
Absolutely. We can stack them, meeting whatever your capacitance, voltage requirement is, and ship it from the factory as a modular solution. So just plug and play right into your application.
That's really great to hear. So Laura, let's say I'm an engineer. What's the one thing I just must remember when I talk about electrolytic capacitors, especially with the rectangular shape?
Well, they are really breaking free from the limits that cylindrical capacitors have that we've already talked about. They have high ripple current capability. They offer a space savings, whether it's PCB footprint or if there's constrained height, they work a lot better there. And it's not a niche product. It's really designed to be the platform for the next generation of automotive and industrial systems that we're seeing.
Well, thank you so much for joining us here today at Ask Why, where we discussed our rectangular capacitor solutions and how they actually breaking the mold quite literally out of the cylindrical into the rectangular shape, and how they really have much better volumetric efficiency, can fit into tighter spaces, and really have less board space wasted. So with that, I want to thank everybody for joining us today, and until next time, keep on asking why.